All right, third example. So this word problem says the radius of a circle is increasing at a rate of 6 millimeters per second. I didn't want to take up too much board space. So if you're thinking, well, how can the radius of a circle increase? Think about like water dripping onto the floor and it makes a puddle in a circular shape. And that puddle keeps getting bigger and bigger and bigger, but in a circular motion. So the radius of a circle is increasing at the rate of 6 millimeters per second. I want to know how fast the area of the circle is increasing when the radius is 10 millimeters. So again, you have to know what formula to use. So it says how fast is the area of the circle increasing? So that right there tells you need the area of a circle. All right, so area of a circle is pi r squared. So write down the area formula and let's take the first derivative with respect to time. So if we take the derivative of a, keep in mind this would be 1, just like the last example. So the first derivative of a is 1, but we're taking the derivative of the area with respect to time. So we have to write dA dt. That equals, keep in mind pi is a number, all right? So we get 2 times pi, which is 2 pi, r to the first for our first derivative, but we just took the derivative with respect to r, so we have to write dr dt. So there's your first derivative of your area formula with respect to time. And just like I did in the last example, I'm going to get rid of this one. We don't really need it there. All right, so we have 1, 2, 3 variables in this formula. So let's list them. dA dt, r, and dr dt. Let's figure out what we know and figure out what we're solving for. So it says, how fast is the area of the circle increasing? So we want the rate of change of the area with respect to time. So dA dt, the rate of change of the area with respect to time, that's what we're finding, the speed of the area. That's our unknown. So it says, how fast is that changing when the radius is 10? So we have to let r be 10. And then it says the radius is increasing at a rate of 6 millimeters per second. So the rate of change of our radius with respect to time is 6. So now we have everything we need. We're just going to plug it in and solve for dA dt. So dA dt is equal to 2 times pi times our radius, which is 10, times dr dt, which is 6. So we get dA dt is 2 times 10 is 20, times 6 is 120. So you get 120 pi. That's your exact answer. So the area is changing at 120 pi millimeters squared per second. And keep in mind it's asking for the rate of change in the area, so you have to have millimeters squared. That's your exact answer. If we go one step further and actually find that on the calculator, it comes out to 376.99 millimeters squared per second. So that's the rate of change or the speed of the area of that circle. So your job is to complete the worksheet. There's only one on there that I think you might struggle with a little bit. It's like, I don't know if you guys have ever gone to one of those. It's like a little bubbler. You can get water, but they give you the water in those little cone cups. They look like this. So you're going to be working with a cone in one of the problems on the homework. I think that's the only one you might have a little bit of trouble with.